Hello, everybody. This video supplements what I did in class today. And the reason why I'm making this video is to help you in your assignment, the second part of week 2 assignment. Okay, it's going to help you a lot on that. And the video is going to be on Euler's approximation. Euler's approximation of ODE. Now, we've seen that you can solve some ODE by first order linear ODE by integrating factor method of integrating factor. And if it is not linear, or even if it is linear, you can still use a separation of what? Separable equations. Separable equations. We can use exact methods. That's what we've talked about in this class. Okay? At least you guys know all this, but some ODE does not have analytical solution. All these methods, we call them analytical solution. Some ODE are very stubborn. They don't even have any. You cannot even solve them by integrating factor. You cannot solve them by separable method. You cannot use exact method. You can't do that. So the only choice left is to use numerical approximation. That is exactly what this video is all about. And the simplest one, I think, and it's very efficient. The simplest one is what? Euler's approximation. Euler's approximation. So let me refer you to, this is a question. If y prime equals t plus 2y, right? And y of 2 equals to 3, find y of 2.5. Using Euler's approximation with h equals to 0.1. Now, let's look at this problem statement. This is ordinary differential equation, right? Y prime, which can be written as the y dt. Although this is not a dot notation, but it's still your variable, your independent variable is t. So you do not use dy dx. You have to use dy dt to do that. And the initial value is this, the value of y when t was 2 equals 3. So when t equals 2, y equals 3. When your t equals 2, y equals 3. Then find the value of y when your t is what? 2.5. When your t is what? 2.5. Given that the time step for making different t's is 0.1. Now, it's not just, oh, this is not started again. Okay. Now, solution. If you remember by Euler's, Euler states that yn plus 1 equals yn plus h f of x y. Right? Now, sorry, yeah, but this time around we are using a t. So this is a t, ty. And in other words, you can say y new because y old plus h of t. You can say t old, you know, whatever. You can say t old, y old. No, I'm just using this. This is not, I'm just using this to what? To explain. Okay. So I have to rewrite this back. Yn plus 1 equals yn plus h f into what? Tn yn. Is that what I have here? Yeah. So you can use T and yn in place of this. Now, we were told that y of 2 equals 3. So when your t was 2, y was 3. See that? Y of 2. And to make different values for t, you have to use time step of 0.1. So you have to start this way. Oh, okay. Okay, now let's go. So you can make up a table, can create a table for n. N is for number of iteration. Maybe you want to do it like 5 times or 6 times. For your assignment, you can stop at 5 times. 5 points. So this is your n. This is a time value, right? That's your independent variable. You must have values for that too. And this is your y value. Okay. And then you can create different point for n. N is 0 to 5. Yeah, that just means how many times do you want to do the calculation? You want to do the calculation 4 times, 5 times? Now, for this one, the calculation is going to be what? Like 6 times. Right? Now, the initial, remember, we have y of 2 equals 3. So your time starts from 2. So 2, and the time step for making up different t's, h equals 0.1. You will need, this is 0.1, you will need this to calculate different values of t. Okay, so the next t is going to be what? 2.1, and followed by 2.2, 2.3, 2.4, 2.5. You see that? And now, when t was 2, remember, y was 3. So you have to put this. So you must have the first row known without any calculation. See, now we want to fill up this place and calculate what? Value of y when t is 2.5. Okay, we started from 2 because h was 0.1. Start adding 0.1 to previous t to get a new t. That's all our t. Now y The formula says yn plus 1 equals yn plus h into, let me see, f of the first one, f1 of first, you can say f. I mean, just say f of, this is your f, right? Let me clean that up. This is your f of t, comma y, tn, comma yn. Okay? Tn, comma yn. If you like, you can call this one f1, you know, or fn. Okay, so now if you look at the differential equation, the ODE says what? It says y prime equals to t plus 2y. So this here, this function here is just your f of ty, because it's a function. It's a function containing t and y. Okay, now let's go by the, we already know our initial y. Let me call it y naught. See this n? So yn, cyn. So our y naught equals 3. So i.e. y value when t equals to 2. So we have, this is done. Now we can now calculate our y1. Y1 will now be y1 equals y naught. Y naught is the previous one plus the value of h, 0.1, times, look at that, times function of t and y. Okay, function of t and y. And this is a function of t and y. It says what? T plus 2y. Now this is your t. This is your y. So that is 2 plus 2y. That's 2 times 3. And everything here. Now the y naught here, don't forget, is just your 3. So 3 plus 0.1 times 2 plus. Let me clean it up. So let me clean it up. So you want to write your y1 as y naught plus h of function of t naught and y naught. Right? Now all the one at the right side, we already have values for them. See, your y naught, when your n was 0, that's your y naught. So your y naught is now, y naught is when your n is 0, that is yn. So when your n is 0, you have y naught. And the value of y naught at this point is 3. This is your y naught. See, so this is 3 plus 0.1 times, now function of t naught is just the right side of the ODE, which is right here. See, the right side of the ODE is the function of ty. But this time around, the first point is when your t was 2 and your y was 3. So, and that says t plus 2y. That is what? 2, which is t. Your t was 2t plus 3 times y. The y is 3. Very easy. So, I mean, 2 times 3. 2 times 3. And that will give you, this will give you 3.8. 3.8. I will do one more. Obviously, your y2 is going to be y1 plus h of f T1, Y1. You have to move to the next point in the table. That is when your, so you have to move to when your T is 1, and that means you have to move to this what? To this point, right? You have to move to that point, and at that point, your Y1 was 3.8. So 3.8 plus your H, still your 0.1 is your H, times F of T1 Y1. Now, do not forget, this is your F of T. This is your F of Ty. See that? It's always T plus 2y. Whatever values you have for T plus 2 times y. Now, here, I have my T to be 2.1. So 2.1 plus 2 times y. 2 times y. Your y was 3.8. And if you do it, if you do that properly, that will give you, what would that give you? That will give you 4.77. And if you continue that way, you will get this to be what? 5.944. This will be 7.3628. And finally, when your T is 2.5, you are going to get 9.0753. You see that? And I've been able to predict that the value of y when T equals 2.5 is what? 9.0753. Okay, that's how this is going to help you for your assignments, the last part of week 3 assignment. Okay, so the essence of ODE is what? Prediction. Prediction. You model scenarios using ordinary differential equation. You solve them, you get a general solution. Okay, this is a solution in Euler's approximation. Now, they gave us all the parameters, and we splitted up the time from 0 to 5, because I need to calculate the value of y when T was 2.5. So the initial value of T was 2. So because our H was 0.1, just keep adding 0.1 to all the T's. So 2, 2.1, 2.2, 2.3, 2.4, 2.5. I have to stop at 2.5 because I don't need 2.6. I was asked to predict the value of y when T was 2.5. So I have to stop there. And that is what? 9.0753. So this is going to help you for your assignment. I hope to see you guys on Friday.